The Hamilton Jet water jet is a highly developed water pump that has been designed for use in a wide variety of marine craft, operating in all sectors of the marine industry. Installed at the stern of a vessel, the water jet draws water from beneath the vessel through a hydrodynamically designed intake screen and into the pump unit. Inside the jet unit, the computer-designed impeller accelerates the water, which then passes through a set of fixed stator vanes. These remove flow rotation created by the impeller to produce a more uniform and powerful high-velocity jet stream. Finally, the jet stream exits through Hamilton Jet's unique JT steering nozzle, where its energy is converted into powerful forward thrust. Each Hamilton Jet water jet features a fully integrated hydraulic control system for steering and reverse functions. The water jet and hydraulics are driven by a marine engine. Thrust forces from the impeller are absorbed by a thrust bearing built into the water jet housing. All thrust loads are transferred to the hull bottom, not the drivetrain or the vessel's transom. Water jets have a number of advantages over other forms of propulsion when it comes to manoeuvrability, durability, and operator ease of use. A key factor in the control of a water jet powered vessel is that, unlike propeller systems, a water jet impeller will always turn in the same direction during normal operation, whether the boat is moving ahead or astern. This means there is no requirement to shift the drive through a gearbox when going from ahead to astern, and provides for very rapid and accurate control of the vessel. This also reduces stress on the gearbox and engine. What's more, a water jet's turning thrust is generated well aft of the vessel's transom, ensuring steering response from a water jet powered boat is immediate and highly effective, and allows for a small turning radius at all boat speeds. The engine throttle determines the amount of thrust provided by the water jet, so will affect boat speed and rate of turn. The helm wheel controls the vessel's heading and rate of turn by moving the water jet's steering nozzle. The ahead-astern control lever raises and lowers the reverse deflector to adjust forward and reverse thrust levels. This can also affect boat speed and steering responsiveness when used in conjunction with engine throttle. The split duct astern deflector works by directing the jet stream down and to each side, so the water flow is kept clear of the transom and water jet intake. The result is high reverse thrust and sideways thrust. With a water jet powered boat, steering response is directly related to engine throttle, not boat speed. The higher the engine revs, the higher the thrust from the water jet, and the greater the steering response. At low engine revs, thrust from the jet unit will generally be reduced, which will affect steering response. However, by lowering the astern deflector slightly and increasing engine throttle, steering response is improved without increasing boat speed. The astern deflector can also be lowered to a central position, where forward and reverse thrusts are equal, so the boat is able to maintain its position regardless of the engine revs. Steering control is still available in this zero-speed position, allowing the operator to fully rotate the boat without moving ahead or astern. Increasing engine throttle at zero speed will increase the rate of turn while maintaining position, and raising and lowering the astern deflector slightly to either side of central will allow you to creep forward or back. In a high-speed emergency, the operator is able to lower the astern deflector into the jet stream without reducing engine throttle to effect a crash-stop maneuver. This will bring the vessel to a stationary position within a very short distance. One important aspect of Hamilton Jet water jet operation is that steering when going astern will be opposite to what the skipper may be used to from operating propeller boats or their car. A good rule of thumb is to remember that the bow of the vessel will always turn in the direction you rotate the helm wheel. With multiple water jets, vessel control is further improved. For example, the skipper will be able to move the vessel directly sideways, which is particularly useful in docking situations. A Hamilton jet-propelled boat is not susceptible to damage from waterborne debris. However, in some circumstances, performance can be temporarily reduced as a result of blockages. At high boat speed, water entering the water jet is drawn from close to the hull itself, so there is little chance of ingesting weed or debris. However, in conditions where there is significant weed or debris in the water, there is some risk of blocking the intake screen at low boat speed, particularly when operating at high engine revs. Symptoms of a blocked water jet intake include an increase in engine revs, loss of thrust, and extra noise and vibration from the jet unit. The simplest way to clear the blockage is to turn the affected engine off and wait for the blockage to float clear before restarting. This is best done while the vessel has some headway. If your vessel has a reversing gearbox fitted, you can reverse the rotation of the water jet impeller to push the blockage clear of the intake. This is called back flushing the water jet. If intake blockages are a common problem, you can have your water jet fitted with an intake screen rake. Activating the screen rake lowers a set of bars down between the bars of the intake screen to push the blockage clear. If something is ingested into the water jet and wraps around the main shaft or impeller, it can be cleared by disengaging the water jet before opening the inspection hatch cover and reaching in to remove the object by hand. Always ensure your inspection hatch is above the waterline before opening to prevent flooding.